Hi, my name is Jack, and this is my CE 570 final term project. So, for this project, I decided to piggyback another one of the classes I'm taking this semester, CE 522, which is Computer Applications in Construction. In that class, we kind of focus on BIM modeling. For this project that I'm piggybacking off of, we were kind of just instructed to build a 3-story office building with a couple unique features, and ours was a glass roof. We'll see that glass roof come up again because the thermal zone that relates to it will be the most hard to consider in our model because it's a large window like that would have poor insulation compared to a concrete wall like the rest of the building, so it'll become an important part of our model. The goal for this project is to take that BIM model and implement an HVAC model to look at the different options through Open Studio and analyze what a good system would be and kind of what loads we would expect at the building. In addition to that, I created a Python collab like we did in class for specifically one of the zones, the third floor office zone, to kind of verify the model in Open Studio and make sure what results I see there through model validation through Python I can confirm are valid. First step I did was I took it's actually a 5D model, but the BIM model from CE 522. I took the architectural plans and I went through and I analyzed what the building makeup is. So I came up with how my node layer analysis will go for each one of the wall types. I divided the building into 3 main types. We have exterior wall, interior wall, and anywhere where there's glazing, we're considering double glaze. Um, I defined thermal zones. We have one at the stairways that goes up. There's one that goes through this ramp system into the roof with the glass ceiling, and then each one of the offices I defined as a zone. And this is how I define them in Open Studio as well. The first part of creating the Open Studio model, after I determined all those things using quantity takeoffs and understanding the zones, I went into SketchUp and I used the plugin like we did for our class project. From that SketchUp model, I was able to define all these different glazing items. One note is I had trouble in SketchUp doing the pyramidal roof, and so what I did instead is I just made sure that the interior volume of air was still the same so that the load wouldn't be too different. And then I continued to make all of those faces glass so that the solar irradiance wasn't too different. From that SketchUp model, I then exported it as an OSM file so that I could open it in Open Studio, and I made lots of assumptions like we did in class, like the location of this building is Purdue. I was able to define the wall makeups using, it's actually this tab in Open Studio to define the exterior walls, interior walls, and what their makeup is and those material properties. Um, with the model being loaded into there, I also was able to define surface relationships. So you see space 101 is this storefront space at the bottom. It's our lobby entrance. And you can see like surface 1 is this bottom floor face here. Surface 1 is boundary condition the ground. And so that surfaces just lets our model know what's an interior surface, what's an exterior surface, what it's interacting with, so that it can do the proper thermal analysis and keep the interior at common temperatures. I also have to define a schedule. So again, like the homework problem that we learned off of in class, I just kind of had a typical schedule for a large office building, with people coming in around 9 a.m., leaving around 5. And for internal heat transfer, internal heat sources, we have all the common things that an office would have, like computers and occupants and perhaps appliances like a coffee maker. From the results, there were 2 main things that I was able to do. So first, when I ran the Open Studio code, I just did an auto-sized VAV, and then from that I was able to define 2 VAVs, and I go into that more in depth in the report. But I defined 2 systems so that I could compare them. The second system ended up being better for actual air control. The first system was able to do things, but it was inefficient. The other notable thing is that what we were expecting, zone 4 was where that glazing was up at the top. You can see as the highest peak load, which makes sense with what we were expecting. So that was a good piece of data to see. In Colab, I just analyzed the 3rd floor, so I defined all these different wall types and defined them into the Python code using the RC thermal network. For the thermal network, I I went through and I said each wall type had a mass load layer and then the surface nodes, and very similar to how we did it in class, where um, it's really just all the different resistances through the walls between the outside temperature and the interior temperature. The solar irradiance was on any face that the sun touched or indirectly touched through a window, so like when it shines in through the window and hits the interior walls. Capactant was any of the mass load layers, so the interior wall and the exterior wall and the concrete layer. From the collab, we got results that were able to tell us kind of what you would expect to see in the Open Studio model and understand whether the two were comparable and whether the assumptions made in each of them made the model. Sorry, it verified the model by showing what we should expect to see as results in the model, and when compared, they were good.